Everyone, welcome to Advent of Code, day 19. In this video, I'll be live coding my solution to the problem so you can see the way I sort of think through things. Today, I'm not actually going in 100% blind. I actually, last night, when the problem dropped, took a look, but was basically just too tired. I only spent like 5 minutes and just realized that it was not the time to be attempting it. So going in 90% blind. And yeah, haven't looked at any solutions or anything like that, or even really thought about it since looking at it last night. I did see though on the leaderboard that this one took almost 30 minutes for some people to complete in the top 100. So hoping to get this done in. Well, I'll probably continue to about 11 my time, which is an hour and 15 minutes. If it takes that long, I'll probably pause. But yeah, let's just get right into it. Day 19, aplenty. The elves of Cure Island are thankful for your help and send you on your way. They even have a hang glider that someone stole from Desert Island. Since you're already going in that direction, it would help them a lot if you would use it to get down there and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they're already forming a formidable heap. Don't worry though, a system of elves is already here organizing the parts, and they have a system. To start, each part is rated in each of 4 categories: X, M, A, and S. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name, and it contains a list of rules. Each rule specifies a condition and where to send that part if the condition is true. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Consider the workflow EX, that's the name. Then we have X is greater than 10 goes to 1, M is less than 20 goes to 2, blah, blah, blah. So named EX contains 4 rules. It performs the following steps in order. It looks at, yeah, so for each one of these rules, it goes through them in order. And then if the condition is true, we go to the rule named 1, or whatever the suffix of the rule is. And then I guess we can also have R and J, where R is reject and A is accept. Yeah. So, okay. The elves ask you to sort some parts for you. So you're given the rules and the parts, separated by a blank line. And okay, we're turning is adding up the XMS rating for each part, and then summing that over the accepted parts. Cool. Let's just get right into it. At least for part 1, this doesn't seem super hard. Okay, I've already pasted in the input, but let's do the example as well. Yeah, cool. So getting into it, I think we will, instead of calling split lines on the lines, we'll just paste the line in like this, and then we'll have rules, parts equals lines dot split, and then split on 2 new lines. Jeez. Cool. Let's set up the watch script. Just looking at the example, print out the rules and the parts. Yeah, okay. We obviously don't want to escape that, and that looks like it's correct. This is just going to bother me, so I'll change this to string, get rid of that error. Okay, so let's parse. Yeah, let's just parse this. First, I guess we can do the rules. Rule and rules dot split lines. Import regex, name, and then conditions is equal to re.match. Just use the find all format. So the name is A to Z capture group. The name is A to Z plus. Then we have an opening curly brace. Then we have anything. We'll just do dot plus. Then we have a closing curly brace. And then we're running this on the rule. And then 0, print, name conditions, and then let's just break. Yeah, so that looks like it's correct. And then for condition and conditions dot split, a comma, turn that to cond. Yeah, I think we can then do if. Let's just create a rule map. Which will be of type, which will be a dictionary. The key is the name, and then so it's name to the list of conditions. So okay, I guess we can do on list equals conditions dot split, the comma, and then before the last condition, um, so this is a condition string list. We can do we're gonna want, what is the XMAS categories? It's the category comparison, and then the number is equal to re to find all. XMass. And then we have less than or greater than. And then we have some digits. And then create a condition list. And after this loop, we will update rule map name equals con list. If 3 got 1. Okay, gotta do 0. Cool. On list out of end. So you can just make this a tuple of the category, the comparison, then cast into a number. Yeah, and then okay, sorry, there's one more thing we should be including this, and then to like what it maps to. Um, colon E to Z plus. Colon need to be escaped. Looks like this is working for the first one, but not for the second. Okay, A to Z can also be A or R. Yeah, because it can also be accepted or rejected. And then we're going to append the final element of the string list. And then print the condition list. Cool. Let's print the rule too. Yeah, so it looks like it's correct. So here we're parsing the conditions or the rules. And let's also parse the parts. Part and parts. Python cast. I just want to see how we can parse a dictionary. Yeah, we don't want to do like this literal eval thing. So let's look at the back of the input. Okay, so it looks like X, M, A, S are in order. X, M, A, S is equal to X equals Jack sugar for digits, comma, M equals, I guess we can just sort of copy this, paste, 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 add the closing curly brace, and that's on part, and then we have X, M, A, S, part map. I guess this should just be a part list. I guess instead of creating the part list, we can just traverse the map. Yeah. Um, okay, let's see what we're working with here. Okay, so the part is not. See, we have to call split lines, and then X mass is working fine. So now we gotta follow the part and see if it's accepted or rejected. Um, yeah, I guess let's just create a part dict which has keys. Yeah, kind of a lot of work. Okay. Um, cool. So I guess okay, all parts begin in the workflow named in. So workflow is um equal to rule map in while true. Um, this is our workflow. Um, for condition, here, I guess we can unpack it. So for cat comp num maps to in workflow, skipping the last. Um, if comp is equal to less than, um, if part dict part dict category is less than num. I guess we can join these. Um, I guess we can do work if keep track of a total. If um, if maps uh, if maps to is in reject or accept, we I guess we're gonna have a Boolean variable to keep track of when we get to an RNA. done is equal to I guess part done is equal to false. Workflow is equal to workflow or the rule maps to and then geez, I don't know why this is so challenging for me. Yeah, I guess if maps2 is in RA, then we can set part done go to true, and yeah, cool. Now we can do the same thing for the other comparison, or greater than. And then if we're not broken out of, what we should do is look at the final element. In reject accept. And I guess we can add this second variable to part accepted, where this is maybe more complicated than it needs to be, but yeah, maps to go to A, accepted, true. I guess, yeah, if flow -1 equal to A, you want to set part accepted. If part done, break, and then if part accepted, total plus equals sum list, part dict dot values. Why is it saying that these are not accessed? So we do this. It's not closed. This. And then instead of 0, we want to return the total. Part 1 should be accepted. So let's, I guess, print workflow. Where are we printing? Okay, looks like we're getting ourselves into some kind of infinite loop, unfortunately. Um, okay, we're stuck in this loop of is s less than this thing, which it is. So then we go to px. Okay, it's in this here. House workflow equals rule map flow -1. So now that is correct. So let's get rid of this. 194114. Let's get rid of some of these print statements. Run on the full input. See if that's correct. Nice. Okay, on to part 2. Even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort plans individually through all of these workflows, maybe you can figure in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings can have an integer value ranging from a minimum of 1 to a maximum of 4,000. Okay, out of all possible distinct combinations of the ratings, your job is to figure out which ones will be accepted. In the above example, there are this many distinct combinations. Okay, so the part ratings is no longer relevant. We just want to figure out which one of the um okay. Yeah, let's do it. This seems very similar to question 8 or whatever was like the related one, maybe number 5 with the ranges. Okay, so let's copy the thing for getting the rules. We no longer care about the parts. So now going to part 2. Let's again watch an example. Now we no longer care about the parts. Yeah, let's just make sure this is working right. Yeah, so we have our rule map. We want to see. Mm, So I guess what we want to do is take um, a set of ranges where the initial range is looks something like this. X goes from minimum 1, maximum, min, max, not inclusive. And then we can delete that text, but okay, so these are the ranges. And while ranges, range, um, um, range dict is equal to ranges.pop. Okay, so yeah, I think what we want to do is for each one of these ranges, it should be a tuple, I guess, of both the where it is, the current rule, and we'll see how black ends up forming this. But next range to process. Be curious. Okay, it's not messing with this. Cool. Yeah, so we want the next, I guess we have the rule name, and then the range dict. And yeah, it looks like we're loading those incorrectly. So I guess we can go through this rule. Yeah. And then split up the ranges as necessary. Cool. And then like we're returning the total number that accepted. Yeah, okay. So I guess we can reuse some stuff from part one where we have the workflow here. And instead of doing while true, this rule map, rule name, and then no while true, which means we can take this whole thing, decrement it. I don't think we're going to need these anymore. So yeah, we can go through the workflow. Just comment stuff we might not need. Okay, so we're going through the workflow, and now we're going to operate on ranges. Where at each one of these, we're sort of splitting up the range. Yeah. So I think There's probably more efficient ways to do this, but let's just do it super simple. So if the comparison is less than, let's check if I guess we want cat min is equal to range dict cat 0 and then max. Oops. So if comparison is less than, we can check if range, so range above, range below, and then range split. So the range is above. If if cat min is greater than or equal to the num, so let's think if num is like 5 and we're looking for less than min than 5, then yeah, greater than equals to correct. If cat max is less than or equal to num, since since if cat max is 5, then the real max is 4. Yeah, so this works. Thinking about this, if it's the other way, um, so yeah, this is going to be an entire workflow. This will be rule map in, because we're going to need to pop off the front of this as we process rules. So this will be flow. Mean rule map. This line's 149. Yeah, so that looks like it's making sense. Let's just print these on separate lines. Okay, so if length of workflow is equal to 1, this means that it's just the next step. So ranges dot append workflow, a new tuple which has the rule map of workflow 0 and the same dictionary. And then we can continue. Otherwise, yeah, we can do this. So if the range is above, then the whole thing is invalid. So we can do um, ranges.append workflow past this element, and okay, here to do handle AR accept or reject. Um, um, yeah, let's do that after this. So range dict and continue. And this is if it's valid. We have do another little ranges.append, but then we can do rule map to, geez. Otherwise, we have the range split. In this case, we do have the range split. Here. So yeah, in this case, we'll append two new things to ranges. The first is going to be the low, or the part above, which is going to be and then we have to make a new range dict new range dict dot copy, and then range dict new cat. I guess we can have range dict above. So the above is going to be the same max, but then the min is going to be equal to the num. And then the range dict below will be have the same min, and then similarly go to the number. Yeah. And here again, we have to handle AR. And then all these should be continue. Yeah, okay, so you have this key error. So I think what we can do actually, just to make this a little bit easier, is explicitly set rule map A equal to, just make it equal to A. So not even a list. And then no, okay. No, we'll just make it a string literal. Same for R. And then list or string, specifications or string, or stir if. Okay, so now we want to check if workflow is equal to A. So I guess if it's equal to R, we can just continue. If workflow is equal to A, we want to add to the total. For R min, R max in range dict values. This should be 1. Range total times equals R max minus R min. Total plus equals range total, and then continue. Sorry, it's unaccepted. Okay, so we're doing some stuff here. Doesn't give us the answer for the example. That's okay though. So I guess we are handling A and R. Just get rid of this. If type of type okay, what was this problem exactly? Because it's not sure what the workflow is. So this should not be an iterator, it should instead be cat comp num maps to is equal to workflow 0. Okay, all this stuff is going to be irrelevant. Yeah, so it's unsure about what num is. I guess here we can, just because this is being annoying. Yeah, this is a better way to handle it anyways. And then here, move this logic to zero. Yeah. Cool. Now I guess we can try the other comparison. Similarly, we have range of. Yeah, let's just copy this. I'm just gonna zoom out a tiny bit because that's nice to see. So if range above, um, you can sort of swap these two, and then similarly, oh wait, we need to append here. Where here, above and below have split. Here we maps to, here we do range below, and then range split. We essentially, um, or above. My fingers are just not hitting the right keys. Um, Map, maps to, okay, here, we can just swap these two. And this needs to be above, this needs to be below. Here, this needs to be num at max. And then, it needs to be cat min num. Oh, wait, sorry, this is wrong. Um, cool. Because, yeah, this should work now, actually, I think. Let's run this on the full input. Is that the same answers you were getting for part one? What the heck? Yeah, okay. Not the right answer. That's annoying. This could be a problem to debug. Oh no. Okay. Um yeah, let's think about this a little bit. To maximum 4,000. So this number should be 4,000 to the 4, but it's um can have an integer value from minimum of 1 to maximum 4,000. There's y. Oh, that's the solution for the above example. Um, what are we getting for the example? 1674. It's close. It's real close. Um, just makes things extra tricky. Oh gosh. Oh, so tricky. We have this, and then this. Are they the same length? Yeah. Oh no. Okay, let's just think about it, I guess. I wonder if, what if it's not inclusive? Okay, that's not it. Makes sense. There's just gotta be some off by ones going on here. So, yeah, I mean, it must be off by ones. That's why our solution is off by this amount. I think this is fine. This is fine. Um, yeah, it just must be these off by ones. So if less than, let's think of an example range. We have, um, something like 1 to 10, and then num equal to 5. Say we have less than. What we want is of above should be, well, I guess either way we're creating the above and the below the same. So above should be num plus 1, shouldn't it? Yeah, okay. Or I guess this is if we have greater than. Is greater than or equal, if the minimum is greater than or equal to num plus 1, or if the max is less than or equal to num plus 1. Because for example, in here we have 1 to 10, above should go from 6 to 10, below should be 1 to 6. And yeah, I think that if we just replace num with num plus 1 everywhere, that'll fix it. Okay, I think that should be right now. Try this out. Nice. This was a good problem. Kind of similar to something we had before, but I liked it. Clean this up just a little bit. Um, yeah, cool. Let's apply this little rule map trick to a previous problem too, though. Where we found the rule map here, and then um, here we can do get rid of this. Get rid of all of this. Similarly, get rid of all of this, and then here, get rid of if and break, and then if workflow -1 is equal to A, just do this. And get rid of this. Okay, cool. So this just cleans it up. Uses the trick we discovered, part 2 and part 1. And we're getting rid of a bunch of comments and bullshit. Okay, let's go through our solution. So first we parse the rules into this rule map where the key is the name, the list, the value is a list of each of the rules, where each rule contains a category, a comparison, less than or greater than, the number, and then the rule that it maps to. And then, yeah, each list ends with a single instead of this unpacking or like parsing the category and all those other form things. It's just the name of the next one. Then we manually add reject and accept, and map to RNA respectively. Excuse me. Then we iterate through the parts, get the categories and their values, put that in this dictionary, and then we set the initial workflow to be the workflow in, and then we iterate through we can iterate until we have either accepted, or so this loop will only be broken when we've accepted or rejected. Essentially, we just do the comparison, see where we map to, and then if the length of the workflow is just one, or sorry, if we are to the last element of the workflow and it's reject or accept, then we perform those operations. What's key here is we use like rules map. So like say less than, and then we are mapping to accept. Since we've mapped accept just to like A, then the next time we run this loop, we'll skip this whole thing because we only have a length of one, and we're iterating from until the last element. We'll go to here, and then we hit here and break out, incrementing the total as appropriate. Then for part two, parsing, exactly the same, little trick again. Then we're operating on ranges rather than individual parts. Each range has a range for each one of the categories, from the bottom to the top, where the top is inclusive. Then we have this the workflow to be processed with this range. Then while there are ranges to process, we pop off the top one, get the workflow and range dictionary. If the length of the workflow is one, we use this sort of same trick as above, where we can check if we want to accept, or if we reject, then we just throw out this range. We're not appending back to the ranges dictionary. If we're accepted, then we add to the total the product of each of the ranges. So essentially, like if there are 200 possible values for X and then one possible value for each one of the other ranges, then we add 200. If it's 200 for each, then the total number of ranges is 200 to the fourth. Obviously simple combinatorics. Okay, then if we don't have reject or accept immediately, we just have the next workflow being set equal to the where we map to. Then we run these comparison. For each comparison, we check if the range is entirely above, entirely below, or split by the interval, and do slightly different things in each. I mean, it's pretty straightforward. You can sort of skip through to when I was writing this code to see how that, talk through a little bit more about how that works. But essentially, when the range is split, we have to create two new ranges above and below, so the range stack increases in size a little bit. But if we're entirely above or entirely below, the range doesn't increase in size, but we go to the next step in the workflow, which can differ how we process that, whether or not the condition is true or false. Then we finally return this number accepted that we've been incrementing this whole time. So yeah, that's it for day 19. Surprised? Well, I don't know, should be surprised, but I think that went pretty smoothly actually. If you have any questions or comments, leave them in the comment section below. But that'll do it for this video. Trying for the final 5 days, I guess. Well, 6 days, 20 to 25, to actually release my live code day of. We'll see how that goes, but that is the plan. Yeah, thanks for bearing with me this far, and see you in the next video.